All right, so this week we're tackling locations in the CC MathMap curriculum. We're going to break down some of those key concepts, like dimensions, and even the idea of time as like a dimensional bridge. So you can feel really confident going into this week's math lessons with your student.
You know what's really fascinating about this unit is that it starts with these really simple ideas, points and lines, and it uses those as building blocks to reveal these deeper connections between shapes and equations, and even how we see the world around us.
Okay, so let's start unpacking some of this. And I think the first thing that jumps out at me is this word locus.
A locus is really just a set of points that follow a certain rule. So it's like a blueprint for building shapes. So imagine you're an architect and you're designing a circular patio. You would need to mark all the points on the ground that are the same distance from the center point. You're essentially creating a locus, that rule that defines the circle.
So it's not just about where each point is by itself, but more about how they're all connected to each other, the relationship between them.
And what's really cool is that this idea of loci, it applies across different dimensions, which is where things start to get really interesting. Because a locus in 2D, that can create a shape like a circle. But as we move into 3D, that same locus can define a sphere.
And that brings us to dimensions. We're talking 0D, 1D, 2D, 3D, like we're stepping into a science fiction movie here.
I think a good way to think about it is like building a house. You start with a blueprint, right? That's like our 2D representation of the house. But then we use that to actually build the 3D structure. In math, we use dimensions to describe the space that shapes and equations exist in.
So it's a 0D point is like the foundation. 1D is like a single beam, 2D is like a wall, and 3D is the whole house.
I like that each dimension builds on the one before it, and it adds a new layer of complexity. Just like a house can have different rooms and features, shapes can also change and take on new characteristics as we move through those dimensions.
So how can we make this idea of dimensional shifts tangible for our 7th graders?
Think about shadow, a 3D object like your hand. It can cast a 2D shadow on a flat surface. And the shape of that shadow, it changes depending on the angle of the light source. So it's a really simple way, but it's a powerful way to show how a 3-dimensional object can be represented in 2 dimensions.
That's such a good example. We could even use a flashlight and some objects around the house and make our own like shadow theater to really explore how those shapes change in different dimensions.
Engaging different senses can really help make these abstract concepts more concrete.
Okay, so speaking of making things concrete, the curriculum mentions this idea of time as a dimensional bridge, which honestly sounds pretty abstract to me. How can we bring that idea down to earth a little bit?
Think about how we often represent time. We usually use a linear timeline, right? We mark events along a straight line. But if we want to show how something changes over time, we often use a 2D graph. Let's say you have a chart showing your child's height over the years. The vertical axis would be their height, the horizontal axis would be time, and that line connecting the dots shows how their height changed over time.
So we're basically adding a time dimension to create a more complete picture. It's like taking a snapshot and turning it into a movie.
And even though the curriculum doesn't go too deep into this idea of time as a dimension, it's a really great opportunity to encourage your student to think about how we measure and experience time in relation to everything else around us.
One thing I've been thinking about is how all of this connects to equations. We've been talking about shapes and dimensions, but where do equations fit into this whole picture?
That's a great question. Equations are like the language that we use to describe those relationships between points and shapes and dimensions. Remember how we were talking about loci? And how it's a set of points that follow a rule. Equations give us a really precise way to express those rules mathematically.
So instead of saying all the points that are the same distance from the center, we could write an equation that basically says that same thing.
And just like shapes can transform as we move through dimensions, equations can also evolve. To represent those changes, let's take the equation of a circle in 2D. It's a fairly simple equation with x and y coordinates. But if we move into 3D and think about a sphere, that equation changes to include a z-coordinate. So it's the same underlying principle, but the equation itself reflects that added complexity of the 3rd dimension.
That makes sense. It's almost like adding another ingredient to a recipe. The core elements are still there, but the final result is something totally different.
I like that analogy. And just a chef needs to understand how different ingredients interact. Our students need to understand how those extra variables and terms in an equation affect the shape it represents.
Okay, so how can we help them make that connection? Because it's easy to get lost in that abstract world of equations.
Visualization is really key. Encourage your students to sketch graphs of equations, even simple ones like the equation of a line, because seeing that line emerge on the graph paper can really help them to connect those abstract symbols to a concrete visual.
Oh, that's a great tip. It's like taking those equations off the page and bringing them to life. I'm still thinking about that concept of time as a dimensional bridge. It feels like there's so much to explore there.
There really is. The curriculum focuses mainly on spatial dimensions, but the connection to time is such a great way to really stretch those mathematical imaginations. We talk about events happening in the past or in the future, but what if we thought about time as an actual dimension?
So instead of just points on a timeline, we could imagine events existing in like a time space, almost like adding another layer to our reality.
I know it's a mind-bending concept, but it really highlights how connected math is to how we perceive the world. And it can lead to some really interesting discussions with your students.
Oh, for sure. I can already imagine the questions coming up. What if we could travel through time? Would the past and future exist at the same time in this time space?
Those are the exact kinds of questions that can really foster a love of learning.
It's about realizing that math isn't just about numbers and equations. It's really a tool for understanding our universe.
That's a beautiful way to put it, and I think that brings us to a key takeaway for this whole deep dive. Encourage your students to think beyond the textbook, connect these concepts to real-world examples, explore their historical context.
I don't know about you, but I'm feeling super energized and ready to tackle this with my 7th grader.
It's one thing for us to understand these concepts ourselves, but then there's the challenge of making them accessible and engaging for our students.
So let's talk about some practical tips. How can we bridge that gap between the abstract ideas and those tangible learning experiences?
One really powerful way is to tap into their natural curiosity and encourage them to become locus detectives in their own homes.
Locus detectives, I love that.
Yeah. So challenge them to find objects that embody that concept of a locus. Like, for example, a lampshade. That's actually a frustum. It's a cone with the top sliced off. And they can even measure the distances from the top and bottom circles to see how that locus rule plays out in a real object.
Oh, that's a great idea. And while they're at it, they could be on the lookout for different dimensions too. Like a drawing on a piece of paper is 2D. A building block is 3D.
They'll start to see that these math concepts are all around them, embedded in the design of everyday things.
So what about equations? Any tips for making those feel less intimidating and more relevant?
I always like to use cooking as an analogy. A recipe is basically an equation with ingredients as variables and the final dish as the outcome. So like baking a cake that involves precise measurements and ratios, just like a mathematical equation. They can see how changing the amount of one ingredient, like sugar, can affect how the cake turns out. It's a delicious way to learn about variables and proportions.
Before we wrap up, I'm remembering that idea of time as a dimension. Any suggestions for how to explore that one with a 7th grader?
Instead of just talking about time in the abstract, try connecting it to their own personal experiences. Help them create a timeline of their life, mark down those significant events, and then have them imagine adding another dimension to that timeline, like their emotional state at the time, or where each event happened. Suddenly, a flat timeline becomes this multi-layered tapestry that represents the richness of their life.
That's such a beautiful way to think about it. Like how time and emotions and places all weave together to shape how we remember things.
I think that's what makes this week's CC MathMap curriculum so special. So to all the homeschool heroes out there, embrace this week's curriculum, have fun with it, get creative.
And on that note, I think we've come to the end of our deep dive into the locations unit. We've covered so much ground, from loci and dimensions to equations and even that unexpected connection to time.
We've talked about practical tips, creative activities, and thought-provoking questions to help you guide your student through this math adventure.
But most importantly, I think we've reminded ourselves that math is so much more than just numbers and symbols. It's a way of thinking. It's a language of patterns. And it's a key to unlocking some of the biggest mysteries of our universe.
So until next time, keep exploring, keep questioning, and keep that mathematical spark alive.